let us now discuss the last topic of our class today, the degrees of freedom. Okay, so let us discuss the degrees of freedom. The degrees, what we mean really by degrees of freedom of a dynamical system. Okay, well, what do we mean by that? As the name suggests, if you just read or even look into the name, degrees of freedom, it means the number of independent ways by which or within which a dynamical system can move or is without any constraint, without violating any constraint. Okay, so if you have constraints applied on a system, then its degrees of freedom gets restricted, isn't it? Of motion gets restricted. So satisfying those equations of constraints, the number of independent ways, so satisfying the equations of constraints, all right, the number of independent ways the number of independent ways of describing the motion of a system, of describing the motion of a system. We call this the degrees of freedom of a system. Okay, all right. Now, how do you, let us put it as an example. If suppose say a particle is moving, is constrained to maintain, if particle has to maintain some constraint equation, if there is a constraint in the motion of a particle, which is say actually moving in 3D. So for a particle without any constraint and it's moving in 3 dimension, the number of degrees of freedom is 3. Okay, if you have n number of particles, so for n number of particles moving in 3 dimension, the number of degrees of freedom is 3n. For every particle it is 3. So for n particles, the total number of degrees of freedom is 3n. Now, if the particle is subjected to k number of constraint equations, then the number of degrees of freedom for a system undergoing constraint equation having, not undergoing, having constraints is 3n minus k. So this is a very important observation. You get it in your MCQ, in your exam. So for a system moving in 3 dimension without any constraint, you have 3n degrees of freedom. If on the same system we introduce k number of constraints, so now the number of degrees of freedom, if we call this as equal to m is the number of degrees of freedom. Okay, so suppose if we take some examples on this. All right, suppose if we consider some examples. What are the typical examples for this? Well, when a particle is suppose we are having a system of say two particles separated by a fixed distance, as for example rigid body. Okay, how will you get its degrees of freedom? When two particles are separated by a fixed distance, for two particles the actual number of degrees of freedom is 3 into 2, 6, and it is separated by a fixed distance, so the number of constraint is 1, so 3 into 2 minus 1, so you have 5 degrees of freedom. All right, so what would be the degrees of freedom for a particle constrained to move on a sphere? If you have a particle constrained to move on the surface of a sphere, for a particle constrained to move on the surface of a sphere. Okay, so how will you get its degrees of freedom? So one particle, so 3 into 1, and then you have how many constraint? 1 constraint. Okay, so radius should be equal to a, the radius of the sphere. All right, so it is equal to 2. The number of degrees of freedom is equal to 2. What is the number of degrees of freedom for a, please find the number of degrees of freedom for a simple pendulum. Find the numbers of degrees of freedom for a simple pendulum and for a body on an inclined plane. For a body on an inclined plane. This is for your assignment. Okay. Alright, so let's stop over here.